My name is Jalen Francis, and today I'll be going over a Unix shell, a program in C. So the name for it is JShell, just kind of a play on my name. Here you can see it has all sorts of functionality. You can find the code on my GitHub. So some basic things it does is it handles multiple arguments when you're calling, system calls or anything like that. You can do input and output redirection, supports pipelines, background process execution, environment variables, job control, aliasing, command history, subshell support, logical operators, support for control structures. And then you can also use the up and down arrows. You can move the cursor around. You can do tab completion for commands and files. There's color-coded prompt, directory aware path completion, intelligent command suggestions with the tab, error detection and reporting. And then also you could do scripting with a .jsh extension, have your own environment variable extension and scripts, handle pipelines, redirections, just pretty much everything you can do normally. And then there's also a custom configuration file that automatically runs. Some built-in commands we have are help, which pretty much gives you all the commands that you might need, like just describing what you can do with the shell and how. Pretty much everything you can find in the README. We have the cd command, exit, env, just pretty much a lot of the basics. And then you have job management, so you can see your jobs, move jobs to the foreground, background, terminate, see your history. So yeah, I'll go ahead and go into how you can go ahead and make this terminal. So once you have the repo installed and make sure you're in the directory, you can go ahead and run make, and it's going to go ahead and create all the object files and install JShell. And then if you run this command, and make sure that you can actually run it with your bin, you don't have to run it locally. Okay, so now we can go ahead and open up our JShell. So currently I went ahead and I just have it running just from there. Yeah, now once we're in the JShell, like I said, you can run help and see. You can use the arrow keys to go through different commands. If I go over to the shell, list out, I can auto tab. So say I want to go run something in the source, I can tab and it shows me all the possible options. Same thing if say I go into scripts, I can tab and there's only one file in there, so it automatically selects it. And then yeah, we can go ahead and clear this. And so now I'll go ahead and set up some test cases so we can see how this terminal actually runs. Okay, so to the side, I basically have a lot of test cases that I'm going to run now, and then we can go ahead and see how this works. So I'll go ahead and copy all these commands and we'll dissect it. So echo hello shell, just pretty simple. List, it just lists the current directory. pwd writes out our current directory. Who am I? It tells us the user. And then here we echoed, this is a test with multiple arguments. Got exactly what we put in. And we can go ahead and run ls with multiple arguments, and it works exactly as expected. Now we're going to go ahead and run some environment variables. So first, we went ahead and created a test variable just called testvar and said JShell is awesome, and we echoed it exactly as expected. We unset it and then printed it out again and got nothing since it no longer exists. Okay, and then now we're going to go ahead and print our current directory again, go back. As you can see, we went to outside the shell, and then we ran cd dash, and now we're back where we were. And also note, we could do cd tilde to go to our home directory. I'm going to go ahead and go back. Okay, now we're going to go ahead and test some redirection. So we went ahead and echoed hello file into a file called test file and ran cat on it and got exactly what we think. And then we can go ahead and append the file, run it, and as you can see, appending this line at the end. And if we go ahead, run the line count and take the test file as input, we get 2, exactly as expected. Okay, and then now we can go ahead and run a pipeline. As you can see, we went ahead and ran grep on that. Okay, now if we do multiple redirections, so we take the test file in that we were working with before, and make it all uppercase. Pipe it out and see hello file appending this file. Okay, now we're going to go ahead and test our double ampersand and or operator. Only the first and fourth echoes should actually print because ls obj should succeed and ls non-existing folder should not exceed. And so if we run that, it's kind of a mess, but we'll dissect it because it lists out the obj, it says folder exists. This one, it does not. And as expected to, non-existent folder, it does not say folder not found. And for this one, it does. So that works as expected too, which is good. And so let's go ahead and clear, and I'll go ahead and demonstrate how we can handle jobs. So if we run a sleep 10 in the background and run jobs, we can go ahead and see it's running. We can kill the process, and now it's no longer there. If we run sleep 5, we can suspend it with Control Z, and we can see under jobs it says stopped. If we run it, it's done because 5 seconds has passed. If we go ahead and Control C, also works exactly as expected. If we go ahead, run this, do Control Z, run it in the background, also works normally. It go ahead and puts that back into the background even though we stopped it already. And we can see it has a running tag, and then we can see it just finished. Okay, now we're going to go ahead and move on to alias management. So if we go ahead and create an alias called LL, so I'll go ahead and run that. And we name it ls-lah. If we run our alias command, it'll go ahead and list out all of them, and we can see it right here. And so if I run LL, it works exactly as expected. And if we go ahead and unalias it, so it's no longer in our list, and we try running again, command not found. Now, if we go ahead and try to create a recursive definition, and then we run that, it also says command not found. Okay, now we're going to go ahead and test out our command structures or control structures. So if we go ahead and run this, so if true, then echo yes. So obviously true is true, so should print out yes, which we do, no problem. If we run a nested, so if false, then echo fail. So obviously that's not going to happen. If we do an else if true, so that's true, so we're in this then block now, then we echo nested yes, else echo nested no. And as we can see, nested yes. If we go ahead and run a case statement, so case pattern 1 and pattern 1 echo first. So obviously these two match, so we should echo first. Just echo what we do. If we do the same thing for pattern 2, add that in there, echo second, which is exactly what you'd expect to happen. And if we go ahead and run and test here and say case whatever, it doesn't match pattern 1, pattern 2, so it goes to the default edge, which is exactly as expected. And then now if we go ahead and run a for loop, so for I in 1, 2, 3, do echo $1 done. So I will be created as an environment variable, and we'll run through those. And it prints out 1, 2, 3, exactly what we expected to happen. And then now we'll go ahead and run some advanced combinations. So here we have echo foo, and it's going to redirect it to testfile.txt. If that succeeds, then we're going to cat it and take input of that exact thing. So what we should see here is foo. That's exactly what happens. Here we echo bar baz, and we pipe it and take grep bar, and we go ahead redirect that to out.txt. And then we run another command with the semicolon, went ahead to split up commands, and we want to print out what's in that out.txt. And so it prints out the whole line as grep pulls out. Now we're going to go ahead and test with the subshell. So our subshell is going to print subshell line and another line, and we're going to grep subshell. And then if all of that succeeds, we go ahead and echo found subshell. And so yeah, exactly what we expected. The subshell line pulls that out, and then it succeeded. So I went ahead and said found subshell. Okay, now we have another subshell. So we go ahead and echo hello world, and we redirect that to temp.txt, and go ahead and cat and temp.txt. So it's going to read that all in, right? And then it's going to redirect that to grep hello. And if all that succeeds, we're going to go ahead and print out pass. Yeah, so we went ahead and pull out hello world, and we printed out pass. Okay, and then last test case we went ahead, print out line 1, we grep line, and then we went ahead and changed the lowercase l to uppercase L, redirect that to transform.txt, and then if all that succeeded, we're going to go ahead and cat that text file. And as you can see, we updated transform.txt and went ahead and print that out because all succeeded, which works great. And yeah, now we can test some of our help features. So obviously we've seen help, we've seen CD. If we run env, pretty simple, it just prints out all the environment variables. Export sets the environment variable, unset gets rid of that. We've seen all these. And then now we can also see our history. So if we just run history by default, it shows the whole entire history that's in our file. But if we only want to see so many, if we run history 10, it will just show the last 10 history commands. And then another advanced feature is as we're going through, we can go ahead and move our cursor around. And when we're also tabbing, if it cannot find a directory, it will look through the history. So I went ahead and tabbed there, and I found the prefix CLE. We see the CLE was in our history recently, so I went ahead and tabbed that out. So as you can see, this terminal pretty much goes through all the basics. If we want to go ahead and test out some more, we go into our testing folder. We have a script in here. Pull that up. Very simple. It's just going to print out welcome to JShell. It's going to list all the files in the current directory, create an alias, change directory to temp, and then print out env. So we're going to go ahead and make sure we can run the script. As we can see, welcome to JShell. Run all that in our directory. The env runs. And then finally, once we want to actually leave, we can just go ahead and type exit and press enter, and then we're good to go. All right, so now we're going to go over the actual code. So first, everything starts off in main.c. So we included a few libraries for just standard input and output, things for system calls. We have our signal handlers, and then we have a bunch of global variables just to help out across the different functions. So here we can set our signal handlers, clean up background processes to actually clean up everything, get all the jobs, processes, that type of thing. In our actual main, we initialize the shell, which this is basically including setting up a whole process group, set environment variables, loading the history, initializing our alias, our command registry, our built-in commands, loading our RC file, and so on. And similarly, our shell cleanup does a lot of those things to clean up the background processes, saving history and all that. And then our shell loop basically continuously prompts the user, reads input, and then parses it into a command. And based on the command type, we either execute it or check. Like here, we're checking for exit. If so, we clean up all these background processes and then go ahead and free all our memory. Again, here in the main, we also have a feature so we can go into command mode if the user enters a -c and then passes in additional arguments, because then we can go ahead and parse, execute the command. Otherwise, we also check if the second argument is a script file or not, and if so, we go ahead and execute the script. So just to give some context before we get into the parser and the executor, we have enum basically just stating our command type. So we have simple commands, if, while, for all the structures, subshells, and or sequences. And then a case entry, this is specifically for when we're dealing with our cases. And our command has all sorts of stuff, but not all of these are used. In fact, there's not a single instance where every single one of these are filled out. So we have some, additional checks that we have to do before we check other things because they might be pointed to a null branch. But essentially, this is done so that we can uniformly handle the executing of commands just to make things a little bit easier. Okay, so now if we go ahead and get into our parser, we have a lot of different functions. So first and foremost, whenever you're parsing, you got to tokenize your inputs. And how we actually tokenize, there's a few different things we're looking for. We're looking for parentheses when we're dealing with subshells. We're dealing with our operators for redirection, input and output, ampersands or the ors, and then semicolons, and that's how like we break things up. And then here's a lot of our declarations. We have a parse command. So there's all sorts of special parses we do depending on what we're actually looking at, since this is more so a recursive descent parser. So our parse input's very simple. We just tokenize things and then we just do a general parse command and make sure we free all those tokens since we are storing these dynamically. Parse command just looks at, okay, can we find any of these if, while, for cases, and then generally parses a pipeline, like tries to see if there's multiple things we're looking for. Here, this is basically checking if we're a sequence. So if we're entering multiple commands separated by semicolons, we can build up a branch, more so kind of like a linked list. As you can see, we have a then branch and then an else branch, and so it somewhat recursively builds a linked list to actually run when we're executing. Here we're just checking for ampersands and the ors, and we're setting it the else branch to actually, parse what's after it, and we're gonna have an actual condition. And then our parse if basically goes through the structure of like what our if statement is. Same thing with our while. You can get the idea if you go ahead read through the code. Okay, and then one thing for our actual case bodies, for our parsers, since they're separated by double semicolons, this is something a little bit special, just to make sure we're parsing the actual case statements properly. Like once we have a pattern, if the pattern is a success, like what's in between those, like the actual body of the case. And so of course, as you'd expect, the parse case calls that. Parse simple, it's very simple. Like we're just checking, do we have a subshell? If not, if so, then we go ahead and parse the subshell. Otherwise, we look at all these things and we look at redirections. Our parse subshell goes ahead and does a lot of very similar parsing, but we change up our arguments to make sure we're actually running a own separate instance of a shell and we're in command mode. It also looks for redirection, and we also want to ensure we can, execute pipelines afterwards. And yeah, so a parse pipeline also creates a list through the next, so making sure we're passing one thing into another. And so the parser pretty much sets up a lot of the dirty work for the executor to actually be able to do its thing. So in our executor, we have the evaluate conditions when we're dealing with ifs, whiles, and so on. We have and then we have special executing blocks depending on what we're looking for, like what we're trying to execute. And so, we have executing pipes. It does duplicating, forking, and all that type of stuff. Checking alias expansion, we're making sure. So this here pretty much just checks for aliasing, making sure we're not recursive so we don't get stuck trims the quotes around it, parses the input, and redirects if needed. Lists jobs, lists all our current jobs that we have running. Is script file, does exactly what you'd think it does. Same thing with execute script. Evaluating condition. Executing if block is very simple. If so, like the if, while, and for would look exactly how you'd probably expect. The execute for is a little bit weirder since we're actually dealing with environment variables. Here we have a little bit separate of a command, so when we're actually expanding an alias for a pipeline specifically, it's a little bit of different work we have to do. And so when we're actually executing the pipeline, similar idea, we have to fork the processes and so on. Okay, and then this is our general executing command, which pretty much just sets up. So are we looking at and or, like, so do we have to, pay attention to our actual statuses? If we're dealing with a sequence, we execute, the then branch and then the else branch and so on. And it will be kind of recursive because, say, this else branch has its own thing and it also has a then branch and an else branch. You can get the idea. Here, exactly what you expect. Like if it's an if, you execute the if. Pretty simple. And then finally, if we get down here, we go ahead and fork, and that's how we can run our commands here as our actual handlers. So when we have our child processes, here is just so we can actually free all our command fields, since everything is done through malloc and dynamic memory. Merge commands, execute case. Here's us actually freeing the commands themselves. That's a lot of code there. Okay, now I want to talk into how we actually do our built-in commands. So we have a method register built-in commands, which is pretty simple. And so when we register our built-in commands, we have our help, cmd help, and all that. These are all external variables. And just basically helping set up whenever we run it. This is all done in the main. Here in our actual command registry, this is very helpful, as this is how, when we're building up all these built-in commands, we can actually check, we can register the commands, we can look up the commands, we can list all the commands, and we can clean up and initialize, which are all important to do. And all the execution, fairly simple, based on how we set it up. Constants, this just lists a lot of constants for our actual shell variables, so we're consistent, and this also improves our memory safety. History is another big one, so we make sure we initialize, we can add, and we look for matches and so on. Cleanup, get, size, and also where our history file is actually stored, and that's in the home directory. And then we can go ahead and save and load just so the user maintains. And the code is also fairly simple for these, just based on how we have it set up. Next, another very important file we have is input.c. And this does a lot of the dirty work with the actual handling of the inputs themselves. So whenever we enter tabs, it looks for the path completions. So first, we look for, can we find directory completions first? If not, then we actually go for history matches too. Well, this file, or this method specifically, goes for the get path completions. What I do mean is later, if this fails, then we actually look for our history matches. And yeah, so our read input pretty much just goes through. It looks for things like the enter key as we go on. And this does a lot of important work with the actual cursors, searching for, are we messing with the arrow keys? So are we trying to move the cursor left or right? Are we tabbing? And we also make sure if we do a get path completion, so here we can see we entered the tab key. We make sure we maintain our cursor and reset the space, and then redraw the actual match, or draw everything. And C, notice here, if match is in count greater than 0, then we print out, the path completions. Otherwise, we look for a match, and if we find a match, then we reset all that stuff. Here, otherwise, we entered some sort of arrow key. This checks are we moving up or down, and we're looking through the history in order to figure out what to display. And this is here if we're moving left or right. Okay, another important class we have is just our job manager. This abstracts some of the stuff in our main just to make things a little bit easier, so we can add jobs, get jobs, update states, remove, and so on. And then we also have a job signals, which this helps with some of our printing, handling the actual signals themselves. Here are rc.c and rc.h. These are pretty simple. It loads the RC file, gets the RC, and sources and processes from based on whatever path we have. Then shell.h defines a lot of our methods that we have just to make things a little bit easier, so we know what to look for. And then I know I've mentioned it, and here's how we can set up a configuration file. So you can add comments, and it's pretty easy to figure out. You can set environment variables through the export. Add any sort of aliases you want. These are just common examples just to make things a little bit easier. Okay, last big thing we have to go over is our actual aliases. So we have a struct, and so we have a name and a command associated with it, and we have our alias initial. It initializes the system. It adds the command, and make sure you're adding a valid alias, and you can check that with this function over here. We have a cleanup, a list. You can get, remove, and the code for it is pretty simple. Nothing is too complicated. So yeah, I think overall that about wraps up this Unix shell, how it's programmed, how it actually works. And so certainly there are a lot of improvements we can make with this, but it works pretty well and has functionality. And if there are any bugs, there are ways you can get around it, but I've tried to find as many bugs as possible. There are some limitations. Our control structures are a little bit whack in terms of how we parse. It has to be very simple like inside the actual body of the statements, since the parsing could be better. But overall, it accomplishes what most people would need in their day-to-day life and does it well. If anyone's interested, you can always take this code or use this code as inspiration, modify it, do whatever. Or you can always email me, leave a comment that you found certain issues and I can try to patch it. But just know it can be a lot to dig through this code at first, since a lot of this is done at a very low level. All of this is done in C. And since we're dealing a lot with strings and parsing, it's not necessarily the nicest, but you have full control in what you're doing with the memory, which is nice. But yeah, overall, I think this is a good project for anyone to learn, since it really shows how you can do system calls and run different commands, have your own built-in commands, and just build a nice system. And also, this is almost impossible to accomplish without having some sort of good structure in your code, especially when you get to more advanced features like pipelines, control structures, multiple levels of redirections, and subshells. It does help in making sure you have certain modules and components that you can use and be well structured. But yeah, overall, I hope you guys learned something or enjoyed the video. Remember, my website's in the description, my GitHub's in the description, and you can always contact me anytime. And yeah, so hope you had a good day. See ya.